In this tutorial, I'm going to talk a little bit about the differences between drafting and just drawing. Drafting is a level of precision that we need in architectural modeling and drawing here in Rhino. And the reason we need this is because our two-dimensional drawings represent three-dimensional objects. And so what I have here, just to start off, is kind of a quintessential shape of a house, right? This could be a Monopoly home. And what I have is it's measured here on the origin, and we have three different views: the top view, the front view, and the right view. In architectural drafting, we would call the front and right views elevations. The top view would be a plan. And these views right now are in wireframe mode, but if I right click, I could set them to shaded, and you'll see that some of those extra lines go away. Those lines are called isocurves. They're just ways of subdividing the geometry and telling us a little bit more about it. So as I move around here, you can see nothing changes on my other drawings. If I were to move this object, let's use the move command and just shift it back. I'm going to hit F8 to turn on ortho, and this way it just moves up in the X and Y dimensions. So I can move it here, and you'll see that this shape, this polyline, was what generated this three-dimensional object. And so the first thing I did was actually to draft this shape. But drafting is more than just that. We can use the objects that we see here in these views to create flat drawings. So let's say, for instance, I was going to make a drawing of this top view. So not a 3D model, but I could do that. I could use a rectangle, and I'd want it to be aligned, but for right now I can just put it wherever I'd like. And I know that it's going to be a 3-point rectangle. It's going to be 5 feet wide and 10 feet deep. And again, I'm using the apostrophe to represent feet. A quotation mark would represent inches, and you can do both at the same time. With 10 foot 6 inches would be allowed, but I'll say 10 feet this way, and then I'll use another line here just to show that roof. Right? So instead of relying on the three-dimensional object, I can draw a two-dimensional draft this kind of drawing here that explains what that is. We need multiple drawings to understand exactly how these things relate. And for example, let's draw something here. If I draw a circle of any size here, this is what the circle looks like in plan. Now, that doesn't tell me what it looks like in elevation. It could be a sphere. It could be a cylinder. And so we need other drawings to tell us something more. And that's why we have these other views. So if we went back to our house here, let's just think, well, we can actually draft off of this house. And to do this, I'm just going to use a different layer. So I'm going to make layer 1 kind of my guideline layer. I'm going to draw just some extensions up this way and the center line there. And I'm going to say that the base of my elevation is going to be drafted from here. And then I'll copy things up. I know that I initially made a 5 by 5 by 5 rectangle and then made that peak. So this can go up 5 feet. And then if I needed to, I could even measure the three-dimensional object and say, well, what's the dimension from here to here? So you can see where I'm getting that here in the 3D view. And it tells me that there's a change in the XY, and then there's a delta X, a delta Y, and a delta Z. And so my delta X, it's moving 2.5 feet over, that makes sense. And it's moving 2.768 feet up. That's not a really great dimension, right? So that's not an even foot, that's not even inches. It should be probably 2.75 feet if I had made it with more precision. And we can do that here in the drawing. So 2.75 feet, that would be the top point. And this is really important to get and understand, that your two-dimensional drawings are what generates three-dimensional objects, and vice versa. We can use those three-dimensional objects to generate two-dimensional drawings of those objects. So let's go back here to, let's say, layer 2. I'm going to say polyline, and now I can use these vertices here, and let's make sure that I use like intersection, INT. So that would snap here, here, here. This is that midpoint of the roof, down here and down there. Now I'll turn off layer 1 by clicking the light bulb, and that'll hide it. And so now here what I've done is draft the kind of site plan or top plan. We're looking straight down at the roof. I've drawn an elevation here, and I could use the same technique to draw something on the side. But I did mention that this shape is slightly different, right? My height on this 3D object wasn't quite what I wanted. So I can go back and I can use these two-dimensional objects to generate three-dimensional things. To do that, let's just look here in the top plan. I know that I want to use some new commands to generate 3D objects, and I kind of want this thing to be turned 90 degrees and extruded. The command in Rhino is called extrude. There are other ways to kind of get 3D geometry, but let's start with that one. So what I'm going to do is just take the plan and the front elevation. I'm going to copy them with the copy command, and I'm going to slide them over this way, say 15 feet. 15 feet, there we go. And that's, I move them a known dimension so that I can always come back and change that dimension if I need to. This piece here, we're going to want to rotate it. So we can do that a few different ways. You can see that it's highlighted here in the right view. So let's just use a command called rotate. And what I want to do is just look, if my mouse is here on the edge, I can see that it's actually located here. Right? If I hover over the 3D perspectival view, I see there's a little highlight on my right view. So I can say that, this is fine. This is my rotation point, and I'm going to rotate. Remember to always read the command line. It says angle or first reference point. Well, this will be my first reference point, somewhere over here, and I'm going to rotate it up this way. There we go. So now I've rotated that piece of geometry. I'm going to then say move, and I'm going to move this point here to this point here, so there's an alignment. Then I can use the command extrude, and it's extruding a curve, and we can look at the command line once more and see that there are options for us. We're generating a surface, that's fine, and I might want to generate a solid. What that'll do is then close off the outside, so it's fully solid. I will drag back, and I know that this is 10 feet deep, so I could even type in 10 feet. That's the depth of the extrusion. Enter. And there we go. Now, this was my original 3D geometry. This is my new geometry based on what I see here in my 2D drawing. There are a few other commands that we can look at right here, and those kind of go into how we might make further manipulations. We've looked at rotation and we've looked at moving. And those are both called transformations, geometric transformations. There are other ones that we can look at as well. If we wanted to make this house not 10 feet deep, but maybe 20 feet deep, we could scale this rectangle. If I type the command scale, you'll notice that I can read the command line and set the base point. Say it's here. Then I can say my reference point is here, and as I drag this way, you'll notice that it scales proportionally. You can see it just gets bigger. If I didn't want to scale uniformly, I can use the command scale 1D. Scale 1D lets me transform this object in a single dimension. So if I scale from this point, and I'm going to use this as my reference, and I'm going to tell it now to be 20 feet deep, it has now redrawn that rectangle so that it is 20 feet deep instead of 10 feet deep. I could then come back to this thing and say I'm going to extrude right along here, and now I have a 20-foot deep house instead. If I ever needed to, I could make a copy of this and think about how I might transform this again. Let's take this object. I'll use rotate, and I'm going to rotate the object 90 degrees. Now I can decide, well, where do I want this to kind of be aligned on my first house? Maybe I want something over here. Maybe I want to use this and move it perpendicular so those two roofs kind of intersect perfectly. Now, this is one way of using those tools. This isn't kind of the best perfect geometry here. We actually have two pieces of geometry that overlap, and later we'll get into a series of commands that are called Boolean operations to do things that would difference or intersect or work with overlapped solids, but that'll be in a few tutorials. So This is just a little bit about thinking about drafting and precision using guidelines, naming those, like, right, it'd be helpful if this was named, and using the geometry to create 3D objects. If I wanted to do something slightly different than that, the opposite direction, I can. Rhino has the ability to make two-dimensional drawings from 3D objects. So let's start here in our top view, and I'll use the command make 2D, and I will generate a top view from the view from our input objects, and we're going to generate both hidden lines and we're going to group everything. We will get into a greater level of detail in a future tutorial that looks at the Make 2D options, but in this kind of explanation of what drafting and drawing can be in Rhino, I want to show you that here I can make a new layer called Make 2D, and I will then move this drawing up this way so we can take a look at it, and you'll see that it's the same color, it's the same color from this layer, but Rhino generated a 2D flat drawing, and we see that flat drawing here. The dashed lines you see are hidden lines, lines that we don't see on the object but are hidden within. And this also works in three-dimensional views. So if I click this stuff here and say make 2D, it'll make a new drawing for me based on that three-dimensional view. So I'll move it up here. And you can see it's a flat drawing. It has no Z height to it, but it represents that 3D object. As you proceed with Rhino and as you work on these techniques, it's really important to maintain kind of a neat and organized drawing. This kind of level of precision will really be advantageous. You know, generating things and just randomly moving them as I've been doing it this way, or if I were to make copies and not know where this stuff would go, this can be confusing and challenging to kind of get things to align, or if, you know, transformation needs to take place, we may not be able to easily do that. So I encourage you to work with precision, but I hope you can see that with that precision you can really generate great three-dimensional models and then use those three-dimensional drawings models to generate very good two-dimensional drawings.